10 interesting facts from the world of computer science. Let's go! The world's first webcam was built for coffee. The world's first webcam wasn't built for video calls. It was built by Cambridge scientists in 1991 to avoid walking to an empty coffee pot. Sick of wasted trips, they wired a camera to an Acorn computer to capture one grayscale frame per second. To save network bandwidth, their custom software only updated users' screens 3 times a minute. In November 1993, this feed hit the web, officially becoming the first webcam. Just don't call it the first internet live stream. That title actually goes to a June 1993 broadcast of a band called Severe Tire Damage. The Space Invaders difficulty accident. The famous speed up in the 1978 Space Invaders wasn't a deliberate design choice, it was just a quirk of the hardware. The system's processor lacked the power to redraw the whole screen at once, so designer Tomohiro Nishikado coded the engine to update exactly 1 alien per screen refresh interrupt. At the start of a level, moving the full 55 aliens form took 55 separate interrupts to complete one movement cycle. But as players blasted the aliens, that activity got shorter. With fewer sprites to process, the system needed fewer interrupts to cycle through the survivors, causing the swarm to naturally move faster and faster. Nishikado realized that this accidental acceleration created a massive adrenaline rush and left it in the game. Linux was almost named Freaks. The operating system powering the vast majority of global web servers and every Android device was almost officially named Freaks. Back in 1991, Linus Torvalds was building a free open-source kernel and locally called it exactly that, a mashup of free, freak and X for its Unix-like roots. But when the code was uploaded to a public FTP server, administrator Ari Lemke basically went rogue. Lemke disliked the original name so much that without even consulting Torvalds, he created the public repository called as pub OS Linux. Torvalds ultimately consented to the change, admitting the new name was better and actually cementing the title of the software that would permanently alter computing history. Software used to be literally woven by hand. We usually think of coding as typing, but the software that navigated the Apollo spacecraft to the moon was physically sewn together. Standard data storage was too fragile for the extreme vibrations and cosmic radiation of spaceflight, so the MIT Instrumentation Laboratory used something called core rope memory. They sent their code to Rayton facility, where skilled textile workers and former watchmakers literally wove the data by hand. If they threaded a sense wire directly through a tiny magnetic ferrite core, it read as binary 1. If the wire bypassed the core, it was a 0. Because a single core could host dozens of wires, the resulting memory modules were incredibly dense and practically indestructible. You can learn more about the mission in this video. Your USB-C cable is smarter than Apollo 11. The Apollo guidance computer was a 1960s marvel, navigating a moon landing with 1024 kHz clock speed and exactly 4 kilobytes of magnetic core RAM. Today, if you crack open an active USB-C fast charging cable, you'll find a microscopic ARM Cortex-M0 microcontroller hidden inside the connector tip. Its only job is to negotiate power delivery protocols to safely route high wattage power to your laptop or device. But running at 48 MHz with 32 kilobytes of flash storage and its own 4 kilobytes of SRAM, that tiny cable tape literally packs vastly more processing power than NASA used to put humans on the moon. The B in B3 is total mystery. Almost every major file system and database runs on a self-balancing mathematical structure called B3. It's the hidden engine behind Windows NTFS, Apple's APFS, and massive Postgres databases. Invented in 1961 by Rudolf Bayer and Ed McWright at the Boeing Scientific Research Laboratories, the duo intentionally left the B undefined in their original paper. It perfectly describes a balanced or bushy and even points to Bayer, but they literally kept it vague because directly naming it after Boeing risks corporate trademark issues. As McRide later joked, the more you think about what the B in B-trees means, the better you understand B-trees. Not sure about that, but why not, I guess. Super Mario Bros. Recycled graphics to save ROM. If you played Super Mario Bros., and obviously you should, you probably missed one of the most clever magic tricks in early gaming history. Hardware limitations in 1985 were brutal, with the NES cartridge allocated just 32 kilobytes for game logic and a tiny 8 kilobytes for all graphical data. To squeeze an entire kingdom into that 8 kilobyte visual buffer, designers Shigeru Miyamoto and Takashi Tezuka had to aggressively recycle assets. Instead of drafting separate environmental art, the team took clouds in the sky, applied a green hardware color palette to them, and mapped them to the ground to act as bushes. Did you notice? Oh, and I noticed you didn't subscribe it. Fix it. Modern CPU guess the future to run faster. Your computer's processor is so fast that it actively predicts the future just to avoid sitting idle while waiting for slow RAM. To keep things moving, CPUs use an architectural trick called speculative execution, literally guessing the outcome of an operation and running the code ahead of time. If it guesses wrong, the CPU simply flushes its state and starts over. In 2018, security researchers discovered a massive flaw. Those discarded wrong guesses left tiny readable footprints in the hardware cache. By using side-channel attacks to read these traces, researchers exposed two of the biggest vulnerabilities in computing history: Spectre, which abuses this prediction trick to force programs to leak their own data, and Meltdown, which exploits the processor's out-of-order workflow to bypass system security barriers entirely. Dijkstra invented network routing without a pen. The mathematical logic behind modern GPS routing was invented entirely inside a man's head during a 20-minute coffee break. In 1956, computer scientist Edgar Dijkstra was sitting on an Amsterdam cafe terrace with his fiancée, trying to figure out the shortest mathematical route between Rotterdam and Groningen to demonstrate the new Armac computer. Because he didn't have a pen or paper, he was forced to hold all variables in his working memory. This strict mental constraint forced him to strip away every bit of avoidable complexity. The result was Dijkstra's shortest path algorithm, which he later coded into the machine using a 6-bit graph limited to exactly 64 cities. That single moment of pure mental focus without a notepad is the reason your phone knows exactly how to get you home today. The 500-mile email bug. Imagine a help desk ticket that makes zero sense. Users complaining they physically can't send emails further than 500 miles away. Between 1994 and 1997, UNC sysadmin Trey Harris dug into this impossible claim and found a wild tech mistake. A consultant accidentally downgraded the SendMail software to version 5, causing it to fail reading the version 8 config file they used till that time. This glitch forced a 0-second connection timeout, dropping any connection that didn't receive a SYN-ACK response within roughly 3 milliseconds. The famous legend claims this 3 millisecond window neatly equals an exact 558-mile radius. But here is a bonus. This last claim was not completely accurate. Data in fiber optics travels slower than light in vacuum, and the TCP handshake inherently requires a round-trip journey. In reality, a 3 millisecond round trip physically limits a signal to a one-way radius of roughly 190 miles. Harris later admitted he simply took license to make for a better punchline. And that will be all for today. If you like what you saw, like, comment and subscribe. And if you really liked what you saw, consider becoming a member to support the channel. Thanks for watching and see you next time. Ciao!